Hello, this is Mrs. Dehn-Brastad, and we are going to do some geometry work today on midpoint and distance in the coordinate plane. This is from Chapter 1, Section 6. Our objectives today are to develop and apply the formula for the midpoint, and to use the Pythagorean, or to use the distance formula and the Pythagorean theorem to find the distance between 2 points. Our vocabulary today is not as much. Coordinate plane, leg, and hypotenuse. Leg and hypotenuse are both from a right triangle. Alright, a coordinate plane is our first word. It is a plane that is divided into 4 regions by a horizontal line, that's called the x-axis, and a vertical line called the y-axis. The location or coordinates of a point are given by the ordered pair xy. If you remember from algebra, this is the x-axis, this is the y-axis. So a point, like say here, would be given by whatever the x value is along here, and whatever the y value is along the vertical axes. You can find the midpoints of a segment by using the coordinates of its endpoints. Calculate the average of the x-coordinates, and to find the average you add them together and divide by how many you have, which will be 2, and find the average of the y-coordinates, so add them together and divide by 2. Here is the midpoint formula using, oops, where did that go from? The formula of it. So the midpoint, you'll see you'll take your 2 x-coordinates together, whatever this one is, plus this one, add them together and divide by 2. And then you do the same thing for the y-coordinates. You add them together and divide by 2. This looks kind of complex, but it's really not when you see some examples with numbers in them. It's much easier if you plot it on a graph, on some graph paper, or even just a quick sketch. So let's look at an example. It says to find the coordinates of the midpoint of segment PQ with endpoints P at -8, 3 and Q at -2, 7. So our first thing to do is to sketch that. So I put a point at -8 on the x-coordinate and up 3 on the y-coordinate, and I put another point at -2, 7, and then you just connect them with this straight segment. That's our segment. Now they want us to find the midpoint. The midpoint is going to be somewhere in there. To find out, we're going to use the formula that says that you should add the 2 x-coordinates together, divide by 2, add the 2 y-coordinates together, divide by 2. That'll give you the coordinates of your midpoint. So we plug in x1, we'll call -8, and x2, sub 2, it really is pronounced sub 2. X sub 2 is -2, and then y sub 1 is 3, and y sub 2 is 7. So when we plug these into the formula, we'd get -8 plus -2, which is -10 divided by 2. And for the y-coordinate, we'll have 3 plus 7 is 10 divided by 2. And we'll simplify both of those, and we'll get that the coordinates of the midpoint is at -5, 5. And if we look at our graph, that looks right there, right where we thought it would be. So it looks like it'll check out. Here's another example to try. We're going to start by graphing it. So we are going to make a coordinate system. We're going to put the point E at -2, 3 and the point F at 5, -3. So here's the graph, and here's the points on there, and then they've been connected with the segment. Now the midpoint looks like somewhere around here. I drew kind of a big circle because I'm not exactly sure. But we'll set it up the same way. To find the x-coordinates, we'll take our 2 x values, add them together, and divide by 2. And to find the y-coordinate, we'll take our 2 y values, add them together, and divide by 2. Now this time something kind of interesting happens with the y-coordinates. So here we'll call this our x sub 1, and this would be our y sub 1, and this would be x sub 2 and y sub 2. So I'll take and add these together. -2 plus 5 is 3, so 3/2, or 1.5 if you'd rather have it that way. And when I add 3 plus -3 for the y-coordinates, I get 0. 0 divided by 2 is 0. 0 divided by anything is 0. So it says that at the point 1.5, 0, right there, that should be our midpoint. They usually label this M as well. If you ever see M, that's usually the midpoint. Okay, here's another example. This time, they're giving us the midpoint. See, there's M. They're giving us the midpoint and one of the coordinates, and they're asking us to find the other one. I would draw a sketch of this to see what it possibly could look like. So I'm going to make I didn't want to draw on top of their solution. So here's my sketch. I know that one of the coordinates of the endpoint is at 2, 7. So about 2 and up 7. And that's the point X. And M has the coordinate 6, 1. So this was at 2, 7. So if I go over, there's 4. So if I go right to the edge of my screen here, that's 6. And 6, 1 would be about right here. And that's M. So that means that my segment is going this way, and I've made it too close to the screen. So my coordinate of my other endpoint is probably going to be something like 10, negative something. The x coordinate should be 10 or 11 or 12 or I don't know, something like that. And the y coordinate must be a negative number because you can kind of see how that line is going to be. Here, let me draw it a little better. I'll just draw farther over. All right, so if we get a little more room here. So our x coordinate was at 2, 7, and our midpoint was at 6, 1. So the other endpoint must be somewhere around here, the other endpoint. We're not sure where, but somewhere in that area. So you can see that it's going, if this is 6 and this is 2, then this looks like about 10 or so, and then it's got a negative value for the y coordinate. So we put what we know into our formula. We know that the x coordinate of the midpoint is 6. We know that one of the endpoints is 2, but we don't know x sub 2. We don't know that one. We know x sub 1 is 2, but we don't know the other one. So right here, this is the main thing right here. You need to find what x is. You could do it with trial and error if you wanted to. You can't cross these 2's out, but what I could do is multiply both sides by 2. That gets rid of the dividing by 2. So now I've got 2 times 6 is 12 equals 2 plus x sub 2, subtract 2, subtract 2. Hey, I did get 10 for my x coordinate. That's kind of what I thought I would get. So this is at 10. Now to find the y coordinate, we do the same thing. We know that the y coordinate of the midpoint is equal to 1. We know that y sub 1 is 7. So there's the 7 there. We don't know what y sub 2 is though. So that's my variable. That's what I'm looking for. That's what I'm trying to solve. Again, we start by multiplying both sides by 2 to get rid of the division by 2. We undo that division. And when we undo it, then there's no more divide by 2, there's no more times by 2, and we're just left with what was inside the parentheses. Then we subtract 7, and we get negative 5 is equal to y sub 2. I knew it would be a negative number. I wasn't sure what the value would be. So that means that the coordinates of our other endpoint, remember we already had one endpoint, will be 10, negative 5. Let's click through here and see if that's what they get to. Here's where they found the x coordinate. They multiplied by 2, they simplified, and then they subtracted, and they also got 10 for the x coordinate. Then the steps for the y coordinate are over on the right side. They got negative 5 as well. So overall, the solution for this answer, for this problem, is 10, negative 5. Okay, here's another one to try. Again, we are given the midpoint coordinates. S is the midpoint. S has the coordinates negative 1, 1. This is x sub 1, y sub 1. So you want to set it up where you're going to be finding both the x and the y coordinate. We know that the x coordinate of the midpoint is -1. So I say -1 is equal to x sub 1 is -6 plus we don't know the other one's coordinate. Divided by 2. And we solve this. And then for the y coordinate, we put, okay, let's see, it's 1 for the y coordinate of the midpoint is equal to -1 plus y sub 2 divided by 2. These are the two little formulas we'll use, and we'll solve these in order to find our missing endpoint. So here's the x-coordinate solution. There's the little formula to solve. Multiply both sides by 2 because that gets rid of dividing by 2. So now we'll have -2 is equal to, now remember on this side, this cancels with this, so we're just left with right here, -6 plus x. Then to solve, we'll add 6 to both sides, and we get 4 for the x-coordinate of the midpoint. Okay, now we got to find the y-coordinate. So over here on the right, you'll see the y-coordinate. We set up that 1, that was the y-coordinate of the midpoint, is equal to the given y-coordinate of one of the endpoints, -1, plus y equals 2. So we'll multiply both sides by 2. We will simplify. Again, the 2's will cancel on this side. And then we'll add 1 to both sides in order to get 3 is the y-coordinate. So we end up with our coordinates of our other endpoint are at 4, 3. Okay, we have a postulate here. It's the ruler postulate that we're going to learn about. It's just how we use a ruler. And we're also going to learn the distance formula. The distance formula is given on the screen. It is a formula of you subtract the x values and square it, and you subtract the y values and square it, and then you take the square root of the whole thing. It's based on the Pythagorean theorem. Let's use the distance formula in these problems. We want to find the length of f to g, we want to find the length of segment FG, and we want to find the length of segment JK. Then we want to see if they're congruent or not. So to find the length of segment FG, we are going to, I'm going to go back for a second. We're going to use the formula, and the formula says that we need to have, let me take a little picture of this here. We need to have this, we need the x coordinates of both of them and the y coordinates of both of them. So the first thing they did is they wrote down what those coordinates were. The next thing that we would do then is plug those points into the formula, which says that we will take x2 minus x1 squared plus y2, y sub 2 minus y sub 1 squared. So this is our x1, x2, if we're going to do FG first. And this would be our x2, y2. We aren't going to use j and k for the first problem. First, we're just going to find the length of FG. So we'll plug these in. So x sub 2 is 5 minus 1. Now it doesn't matter if you decide to let f be x sub 1, y sub 1, or if you let g decide to be x sub 1, y sub 1. Either one will work. You'll get the same answer. And then the y values. Now since I picked that x sub 2 was 5, I have to pick the y value it goes with to be the y sub 2. 5 minus 2. Oops. This looks like an x, but it was supposed to be a y. 5 minus 2 squared. And the square root of this whole thing. Okay, so then we just keep simplifying. 5 minus 1 is 4 squared. Plus 5 minus 2 is 3 squared. Now if I would have got a negative number in there, when I square a negative number, I will get a positive number. That's why it works to let either coordinate be the x sub 1 and the y sub 1. So I get the square root of 16 minus 9. 16 minus 9 is 7, which I cannot take. It's not a perfect square. I could get a decimal approximation of it, or I could leave it as the square root of 7. It kind of depends on how the book wants you to find it. I'll just do both. Square root of 7 is about 2.65. Okay, then you would use the distance formula to find the length of JK, segment JK. and you'll see if you get the same thing. Then you'll say yes, they're congruent, or no, they're not. Okay, so here's the first one. Did I make a mistake on mine? My mistake was, I must have made a mistake because they got a different answer. Oh, do you see my mistake? My mistake is that this is supposed to be a plus sign. So 16 plus 9 is 25, and the square root of 25 is 5. I hope you caught that while you were watching. Okay, so we've solved and got 5. Now we're going to find the length of JK. So we plug in those coordinates, and when we simplify that, we will get, now and you might be a little confused about this part here. This would be -1. Minus and negative is the same as plus. -1 plus 4 is 3, so we have 3 squared. And then -3 minus 0 is -3 squared. So we get the square root of, here let's simplify a little farther first, 9 plus, now -3 squared is the same as -3 times -3, that is also 9. So we get the square root of 18. So is 5 and 3 square root of 2 the same thing? They're not. 3 times the square root of 2 is approximately 4.24, which is not the same as 5, which you probably could have told anyway. So these are not congruent, and you would add that. So say that they're not equal or not congruent, you can just make the congruent sign and then make a line through it saying nope, doesn't happen. This is some more examples to try. They want you to find the length of EF, which is up here, and GH is this one over here. So you'll use the distance formula, and then you'll decide whether or not those are congruent or not. Here's the solution. In this one, we get the same answer for both of those segments, so you would say, yes, they are congruent. Segment EF is congruent to segment GH. Now, you may find it easier to use the Pythagorean theorem rather than the distance formula. They're really the same thing. The distance formula is just kind of condensed. In a right triangle, the two sides that form the right angle are called legs. So if we have a right triangle, this would be a leg, and this would be a leg. And the side opposite the right angle is called a hypotenuse. Hypotenuse. Usually we will call the legs A and B, and we'll call the hypotenuse C. The Pythagorean theorem says that a squared plus b squared is equal to c squared, or sometimes you'll see it written c squared equals a squared plus b squared. It can be written either way. And the Pythagorean theorem says that if you square the length of the legs and add them together, it will equal the square of the hypotenuse. And when we get to chapter 5, we'll do more work with this, but you'll actually do some little proofs that show that if you took the area of both of those squares and add them together, you'll get the area of, that was a little sloppy, that one's square. So this says to use both ways to find the distance from D to E. You've already practiced the distance formula, so let's use the Pythagorean theorem here. The Pythagorean theorem, well, here's the distance formula. Show the steps on that. And we get an answer of about 10.3. Now to use the Pythagorean theorem, you're going to say, okay, I want to do a squared plus b squared equals c squared. So we count the units from here, 1, 2, 3, 4, 5. So 5 squared plus the length of b would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm really counting the bumps here. I'm not counting from here, 1, 2. I'd have one too many if I did that. So I count 1, 2, 3. and so on. So we have 5 squared plus 9 squared equals c squared. So 5 squared is 25, 9 squared is 81. Add them together, you get 106. That's equal to c squared, 106. So to solve, you would still have to take the square root of both sides. And when you take the square root of 106, you can either leave it like that, or you can get a decimal approximation using your calculator, and that's about 10.3. So you get the same answer whether or not you use the Pythagorean theorem or the distance formula. If you have a right triangle graphed, it's probably easier to just go ahead and use the Pythagorean theorem. If they're just giving you the coordinates of points, then you might find it easier to use the distance formula, just for the sake of, saves a little bit of time if you don't have to draw it. But I do prefer the Pythagorean theorem if you're given a graph. It's really a matter of your choice. Either one will work as long as you follow the steps correctly. Thank you very much, and please let me know if you have any questions.